Okay, welcome back. In this fun math video, we are going to look specifically at solving application problems using systems of equation ideas. Now, I want to start by saying there are 1,000,001 different ways that you can solve a single math problem. And these word problems are going to be no different. There are many different approaches that could be used in order to solve them. However, I want to look specifically at using a system of equations in order to solve these problems. Okay? Now, the reason why I'm doing that is because you need to be very careful when solving problems. Some problems are not going to tell you anything other than the problem itself, and the way you solve it is totally up to you. Others, however, are going to specify that they want you to use a specific equation or idea. So you need to know how to approach a single problem in many different ways. So here I'm going to show you quite a few different examples of different problems that can be approached through the methods of using a system of equations. Okay. So let's go ahead and get started. So first things first, we have jazz tickets. So here we have that one evening 1,500 concert tickets were sold for the Fairmont Summer Jazz Festival. The tickets cost $25 for a covered seat and $15 for a lawn seat. The total of the receipts was $28,500, and the question wants to know how many of each type of ticket were sold. So that means we have two equations that we have to look at. The first equation that we're going to have is going to deal with your cost. And the second equation is going to deal with the amount of tickets. So we've got two different equations that we have to look at here. So first we have to design them. Let's go ahead and start out with what we're looking at. We are looking at covered seats and lawn seats. So we need to have variables for those. Most students like to choose X and Y. Now do keep in mind there are 26 letters in the alphabet, so feel free to be creative and choose your favorite variables. Just make sure you designate what those variables are. So for example, let's go ahead and use C, and that is going to be my covered seat, and L is going to be a lawn seat, just to mix things up a little. Now, I know some information about my covered seat. I know that they cost $25. At the same time, I know some information about my lawn seat in that they cost $15. So with that being said, I can create my cost equation. So first and foremost, I know that $25 per covered seat plus $15 per lawn seat has to equal the total amount sold, which was $28,500. Now the other equation has to come from the amount of tickets, and we know that there were 1,500 tickets sold. So I have that my covered seats plus my lawn seat has to give me the 1,500 tickets sold. So if you look, there's your system. So now all you have to do is you just simply have to start solving. If you notice this system, I have one equation here where I have a coefficient of 1. And so an easy thing to do would be to use substitution. However, you can use either. You've got two methods, substitution or elimination. You have to pick which one you like the best. I'm going to go ahead and use substitution method to to solve this one so you can see how that works. So the substitution method says, first I have to choose which equation I want to work with. So I'm going to choose C plus L equals 1500. And I'm going to go ahead and solve for C, which is going to be my 1500 minus L. My second step says that I have to substitute it into the equation I did not choose, which was 25C plus the 15L is equal to 28,500. So I'm going to input in for C, so this becomes 25 times 1500 minus L plus a 15L equals my 28,500. I have to distribute. So my 25 is going to come into both. So this becomes 37,500 minus 25L plus 15L equals 28,500. I need to combine my variables together. And then I'm going to take my 3,700 and I need to shift it to the other side of my equation. So because it's positive, to move it says I have to subtract. So 25 minus 15 is going to give me, or plus 15 gives me a negative 10L is equal to, and then I've got my 28,500 minus your 37,500 gives you negative 9,000. Divide everything by 10 and I get that L is equal to 900 seats. So this would be your first solution. I'm then going to go back to my original equation here, which says that C plus my 900 should equal 1,500 seats. Therefore, C is going to equal 600 seats, and here is your second. Now, to make this complete, we have a sentence, and we have that there were 900 lawn seats and 600 covered seats sold. And there you go. That is using the substitution method in order to solve the system of equations for this problem. Alright, now let's look at another one. So here we have Jeremy inherited $15,000 and invested it into 2 municipal bonds, which pay 4% and 5% simple interest. The annual interest is $690. Find the amount interest invested at each rate. So, again, we have 2 equations. The first one we have has to do with interest earned. And then the second one we have has to do with your amount invested. So let's go ahead and look at the interest earned. Again, we've got 2 bonds. So we need to identify them with variables, and so here let's go ahead and say that we have X is going to be my 4% bond and Y is going to be the 5% bond. So let's create our interest earned. So the amount of interest earned is $690. So when we're talking about percent, remember we need to convert percent to a decimal. To do that means you need to divide by 100. So when we're talking about 4%, that's the same as 0.04. And 5% is the same as 0.05. So here, what do we know? I know that 0.04 of my X investment plus 0.05 of my Y investment has to earn me $690 total. Now, I also know that the total investment is $1,500. So that also tells me that X plus Y is equal to the $15,000. And just like before, here is your system. Now, there's one thing that you need to keep in mind when we're talking about substitution versus elimination, and that is elimination cannot have fractions. It should be whole numbers. So when we're talking about this system here, I have these decimals, so that means I would go ahead and use substitution as my method of choice. So again, substitution says I have to choose an equation. So X plus Y equals 15,000, and I need to solve for a variable. So X is equal to my 15,000 minus Y. I then have to substitute it in. So the second step that we have to do is we need to substitute into the equation that was not picked, so into my 0.04x plus 0.05y equals your 690. So here I'm substituting in for the x, so this becomes 0.04 times your 15,000 minus y plus 0.05 y is equal to your 690. You need to distribute into your equation so that we can look or work to simplify down. And so here we're going to end up with 600 minus 0.04 y plus 0.05 y is equal to 690. Again, I need to combine my variables, and I'm going to take my 600 and I'm going to move it. Since it is added, to move it says I have to subtract. So this is going to be 0.01 y is equal to 90. Divide everything by 0.01 and we get that y is equal to 9,000. Now the next thing that we need to do is we have to solve for the missing variable. So we do that by taking what we just found and plugging it in. So you come back over here to whatever your equations were and you choose one of them to work with. I would choose working with this bottom one, so I'm going to have x plus y equals that 15,000. I already solved for y, so I have x plus that 9,000 equals 15,000. So my x is going to equal $6,000. So these are my two solutions here, 1 and 2. which again means that we can state our conclusion. And your conclusion says that Jeremy invested $6,000 at a 4% bond and $9,000 at the 5% bond. And that would be your overall result. Okay, so that is a second equation or second example of using the substitution method to solve a system of equations. Alright, so now we have the owner of a daily grind coffee shop mixes French roast worth $12 per pound with Colombian coffee worth $9.50 per pound. He wants to create a 20-pound mixture of coffee worth $10.50. How much of each type of coffee should be used? To do this one, I'm going to show you a different setup method. So here, we're actually going to use a table in order to create our system of equations. Okay, so first and foremost, we have to look at what we know. Well, one, we know the cost of your coffee. We know the pounds of the coffee, and we know the value of the mixture of your coffee. And that's going to represent half of our equations. The other part of our table is going to come from knowing that we have French, and then we have Colombian, as well as a mixture. Okay. So when we look at this, what do we know? Well, that's going to come back from the problem. So again, we have a French roast coffee that is worth $12 per pound. So the cost of my French is $12. I don't know how many pounds I have, so we can call that F. And I know the value of this mixture is going to have to be $12 times however many pounds I have. Now my Colombian coffee is worth $9.50. So my Colombian coffee is $950 per pound. I don't know how much of it I have, but I do know the value is going to be the cost times the amount. Last, I've got information about my mixture. So my mixture here, I want 20 pounds of mixture worth $10.50. So the cost that I have here is $10.50. That's my desired. The amount of pounds that I want is 20, which means the value has to be that $10.50 times the 20 pounds I want, which is going to give me a value of $210. Okay. Now, if you pay very close attention and look right here at the table, you can see that we have our two systems, because the amount of pounds of French plus the amount of pounds of Colombian needs to equal the total pounds of my coffee. And the value of my French plus the value of Colombian has to equal the total value of the coffee. So if you look very, very closely, you can see that this right here is your system. And this is how you would use a table in order to create your system for solving. Okay? So now all we have to do is solve it. And again, because I have a decimal here, I would use the substitution method. So the first thing we have to do is we have to choose the equation we want to reduce. So I'm going to use f plus c equals my 20. And then let's go ahead and make f is equal to 20 minus your c. I then have to substitute it into the equation we didn't use. So we're going to substitute it into 12f plus the 950c equals 210. So this becomes 12 times 20 minus c plus 950c equals 210. Alright, so just like before, we need to distribute. So we get 240 minus 12c plus 950c equals 210. So we're going to take 210 minus the 240, and that's going to give us negative 30, and then I have the negative 12 plus 950. So we're going to have negative 2.5 c is equal to negative 30. So we're going to take that negative 30 and divide it by your 2.5. So we get that c is equal to 12 pounds. And this is your first solution. Then the next part is we need to take what we know and we're going to need to substitute it back. So again, we are going to sub into f plus c equals your 20 pounds. So here we've got f is equal to 12, f plus 12, jumping ahead of myself, is equal to 20. Move the 12 and we get that f is equal to 8. So here we have that the mixture is made of 8 pounds French roast and 12 pounds of Colombian. And there you have it. So here we used a table in order to come up with our system, and then we used substitution to solve it. Okay. Alright, let's take a look at another one. See, here we have Jeremy's boat travels 45 miles downstream in 3 hours. The return trip upstream takes 5 hours. Find the speed of the current. So here we're looking for just the speed of the current. So we're again going to make another table so that you can see. But here we have to remember we are talking about traveling. So because we are talking about motion, this means we need to use d equals RT as part of our equation, okay, because we're talking about traveling. So what do we know? Well, we know that we're going to go downstream, and we know that we have to come upstream. That being said, we know that we're going to travel a distance, we know that we're going to have a rate, and we know it's going to take time. So here, d equals RT is what we're looking at across the top. So what do we know? Well, we know that you're going 45 miles downstream. So this is 45. We're also making a return trip. Because of the word return trip, that automatically tells you we are also going 45 miles upstream. Now, for the rate, we don't really know the rate yet. We're going to talk about that in a second, but we do know how long it takes. It takes 3 hours to go downstream, and it takes 5 hours to go upstream. Now, when we're talking about a river, there are two really important pieces of information that we have to consider. First is we have to know the speed of the boat. So let's call that P. And then we have to know the speed of the current. And we can call that C. So when we're talking about downstream, if you notice, downstream is a lot faster than upstream. So the current is helping. So my rate is going to be the speed of the boat plus the current. However, upstream is taking a lot longer. So this is going to be the speed of the boat minus the current, because now we're fighting against that current. So if you again pay or look closely, we have our system. So my distance has to equal the speed or my rate times my hours. So the same for the bottom. My upstream is going to be my rate times the hours. And this is my system of equations. Okay. So what do we actually have here? Well, we have 3 times P plus C equals 45. And I have 5 times P minus C equals 45. The first thing I would do is I would simplify. So the first thing I'm going to do here is you're going to simplify both equations. Now, I know that we can do that because I can pull a 3 out of 45. So this is going to become P plus C equals 15. And then the bottom is P minus C equals 9. So I'm going to use the elimination method. So here we're going to go ahead and use this elimination as my method of choice. And the reason for that is because very easily when I look at it, I know I can cancel terms out and I don't have any fractions. So the elimination method says that first we have to choose the variable you're going to eliminate. So let's go ahead and eliminate your C. So I have P plus C equals 15 and P minus C equals 9. And elimination method says I have to add them vertically. So P plus P is going to give me a 2P. My C's are same coefficients, opposite signs, so they go away. And then here I'm going to have 15 plus my 9, which gives me 24. Divide everything by 2 and we end up with P equaling 12. And this is going to be miles per hour. Now, P, if you remember, was the speed of the boat. And what we actually wanted is the speed of the current. So we're not done yet. We need to come back into your system. Now, provided that you know for a fact you didn't make any mistakes, the second thing that we have to do here is we need to substitute it, and we're going to substitute it into one of our equations. So P plus C equals 15. My P is 12, so I have 12 plus C equals 15. So C is equal to 3 miles per hour, and this was what we were looking for. So my overall solution here would say something along the lines of the speed of the current is 3 miles per hour. And since that's the only thing that I cared about, that's the only thing that is necessary. So, there you have it. We have a motion, distance, rate, time problem solved by using system of equations. Alright, last but not least, we have that Jeremy empties his pocket and finds 42 coins consisting of quarters, dimes, and pennies. There are twice as many pennies as dimes and quarters total. If the total value is $2.13, how many coins of each denomination does he have? So this is what we like to call a 3-variable system. Now the rules for system are simple. Your number of equations must match the number of variables. So a 3-variable system essentially means you're going to have 3 different letters or variables, and that means you need 3 different equations. So the first thing we have to do is we have to look and see, can we create that out of this problem? So, what do we know? Well, we know that there are 42 coins consisting of pennies, dimes, and quarters. So, first I would state my variables. So Q for quarters, D for dimes, and P for pennies. Now, we know that there are 42 of them. So we know quarters plus dimes plus pennies must equal my 42. So that's your first equation. Now, I'm told that there are twice as many pennies as dimes and quarters total. So, the second one is looking at twice as many pennies as dimes and quarters. That's going to be our second equation. So this is telling us that I have pennies is going to equal something. Well, twice as many means 2 times, and then I have dimes and quarters total, D plus Q. 2 equations down. Now we're told that the total is $2.13. So the third equation that we have is going to be your cost equation. So we also then know that a quarter is equal to 25 cents. We know a dime is equal to 10 cents, and we know a penny is 1 cent. So your cost equation has to take that into account, meaning that 25 cents times however many quarters you have plus 10 cents times your dimes plus 1 cent times your pennies has to be the $2.13 that we were given. So we have our 3 equations that we have to use. And they are quarters, dimes, and pennies is 42 cents. Pennies is the following. And our total cost. So we need to set up our system here. So let's go ahead and take a look at it. So I have Q plus D plus P equals 42. Then I have P is equal to 2 dimes plus quarters. And then I have my 25 cents for quarters plus my 10 cents for dimes plus my penny is 213. And this is the system that I have to solve. Now, I have decimals here, so I have to use substitution. And because I have 3 variables and 3 equations, it means I'm going to use the substitution twice. So let's go ahead and take a look at it. First things first, I would start with my pennies equation. So the first thing that I would do is I would simplify your pennies equals twice times dimes plus quarters. And the reason I would do that is to make it a little bit easier when trying to plug things in. To simplify simply means I'm going to distribute this 2 through. So my pennies is actually going to be 2D plus 2Q. Once I do that, I'm going to go ahead and I'm going to substitute into one of my equations. And the first thing I would do is I would substitute it into my top equation. So Q plus D plus P equals the 42 coins. And I've already told you what P equals. So here we're going to get Q plus D plus, and then it is the 2D plus 2Q equals 42. Combine my terms, 3Q plus 3D equals my 42 coins. And then I would go ahead and simplify, which says I can divide everything by 3. And therefore I get that Q plus D equals 14. So this is my next new equation. So I need to keep an eye on that equation. But then I still have 3 variables here. So I have to substitute again. So my second step, or my third step, is going to be that I need to again substitute into my equation 0.25Q plus 0.10D plus 0.01P equals 213. So let's go ahead and actually do that. And what I'm substituting in again is going to be my P. So here, what we're going to do is we have 0.25Q plus 0.10D plus 0.01 times 2Q plus 2D equals 213. And that is substituted in. Okay. So now we can go ahead and simplify this down. Let's go ahead and do that. Let me move this other one out of the way here. Alright, the first thing I need to do is I need to distribute through. So I'm still going to have that 0.25Q plus 0.10D, and now this is going to be plus 0.02Q plus 0.02D equals your 213. Combine my terms, 0.27Q plus 0.12D equals 213. And here is my next 2 variable equation. So in looking at these, what this means is that I now have a new system. So I need to take a look at what that new system is. So my new system is going to be made up of the initial first simplified, so this equation here, Q plus D equals 14. So we have q plus d equals 14. And then I have my second one, 0.27q plus 0.12d equals 213. And this is a new system. Again, I have to use the substitution method. In order to simplify. So we're going to do it again. First thing I'm going to do is I am going to choose my equation, q plus d equals 14, and I'm going to solve it so that q is 14 minus d. The second thing I'm going to do is I am going to substitute into the equation I didn't use, so the 0.27q plus 0.12d equals 213. So this becomes 0.27 times 14 minus d plus 0.12d is equal to 213. So here I have to distribute through. So I have my 0.27 times the 14 is going to give me 378 minus 0.27d plus 0.12d equals 213. I need to combine my two variables, but then at the same time I also need to move my constant. Since it's positive, I have to subtract. So here I've got my negative 0.27 plus my 0.12. It's going to give me 0.15d is equal to my $2.13 minus the 378, which is going to give me the minus 165. And then I need to go ahead and divide. So the negative 165 divided by 0.15, don't forget your negative, means that your d is going to equal 11. Okay, so this is your first solution. Now, we then have to go ahead and do your next step, which says that we have to substitute backwards. So I have one answer, so I'm going to go up to my closest system, which is this one here, and I'm going to choose one of the equations in order to use. So I'm going to substitute into q plus d equals 14. So here this is q plus 11 equals 14. So q equals 3 is my second. And then the last thing I have to do is, again, I have to substitute backwards one more time, which means I have to come all the way back to my original system here. And again, I've already have an equation for pennies. Pennies equals twice dimes plus quarters. So I'm going to substitute into p equals 2 of dimes plus quarters. And so here my pennies is going to be 2 of my 3 plus 11. So this is going to equal 2 times 14. So my pennies equals 28. So my solution here is very simple. We have that Jeremy has 11 dimes, 3 quarters, and 28 pennies in his pocket. And that is how you would solve a 3-variable system. Alright, so I know that just packed a lot at you as we looked at all those different examples of being able to solve systems of equations. So if you have any questions, please let me know. Otherwise, be sure to have lots of fun. Remember your substitution rules, and I'll see you next time.